Now actually, if we know just the value of the power function y equals x to the p at -2 or at -1/2, we can figure out all the rest of the values. Now actually there's no figuring on many of the values. We know that when x equals 0, if p is a positive number, so let's make sure we understand that p is a positive number. Just knowing that the value of the power function at -2 is -32 will allow us to determine all the rest of the values. Now, some values are just automatic. We know that when x equals 1, y is going to equal 1. That's going to be true for every power function. So if we try to make a table for a power function, so we've got -2, -1, -1/2, 0, 1/2, 1, 2. Okay, y equals x to p for p greater than 0. We know that 0 is going to give us 0. Now, if p was a negative number, we would know that p of 0 is undefined because a negative power would be a reciprocal of a positive power, and we'd have a division by 0. And we understand that, I hope. Okay? And we know that when x is 1, that the value is going to be 1. Now, we don't automatically know everything else. Okay? But if we know the value at -1, that gives us even more information. If the value at -1 is either going to be -1 or 1. So if the value at -1 is -1, well, we know that all the rest of the values for negative values of x are going to be negative. And if the value at -1 is +1, we know that the y values for all these x values are going to be positive. And we're used to that. We've made these tables, I hope, plenty of times. Okay. So, there's another relationship that we'll discover here. If x is -2 and y is -32, then what does that tell us? Well, it tells us that when x is negative, the y values are going to be negative. Okay, so that would tell us for this function that if this is -32, then we have to have a negative here and a negative something when x is -1/2. And then we'll have to have a positive something from 1/2 and 2. Well, let's see. How could the value at -1/2 be related to the value of -2? Okay, let's just see what we can see from these tables. Let's see. For the function x squared, I haven't done the whole table, but when x is -1/2, x squared is a fourth. When x equals 2, you can verify that the value is 4. Unfortunately, I got a little careless there, even though I did plot it correctly. Okay, so the value at 1/2 and the value at 2 are reciprocals of one another. The value at 1/2 and the value of 2 are reciprocals. And I was careless again, that should have been -1/8. But you have reciprocals, okay? No, sorry, 1/2, it's 1/8. Okay. And here I have reciprocals. In other words, the value of 1/2 and the value of 2 are reciprocals. That's, of course, because 1/2 to a power is 1 divided by 2 to that power, which is 1 divided by 2 to that power. Now you can think about that and reconcile for yourself why that has to be the case. So that at 1/2, I know that the value has to be -1/32. Then, by symmetries, I know that at 1/2, the value is 1/32, and the value of 2, of course, will be the same as the value of -2 except positive. And I'd have my whole table. Now, if I'm trying to do the graph, I don't have to write the whole table. I just know that, okay, here I got -2, and here I've got, whoops, that's got to be down here. Well, it's not necessarily going to be convenient. We have -32 down here, and I better redraw that. Okay, so say negative 32 is down here, and negative 2 is here. So there's a point on our graph. Now we know that at negative 1, well, the value of this thing is going to be negative 1. That's going to be very close to the axis on the scale I'm using here. And at negative 1/2, the value is going to be very close to 0. It's going to be 1 over, or negative 1 over 32. The value is going to be 0 here, so we can easily sketch that much of the graph. Then the other half of the graph is just going to be the same shape when flipped over. And the values will be what they are. Now you need to work through, I'm not going to be too explicit in explaining this. This is an overview of how you can reason this out. For the graph of y equals x to the p when x is negative 1/2, and we know that y at negative 1/2 is 1 over 4,096. So at negative 1/2, let's say here's negative 1, so here will be negative 2, here's negative 1/2. Negative 1/2, this thing is 4,096. That's a huge number. Okay, here's 4,096. At negative 1, it's going to be what? Well, this is positive. At negative 1, it's either positive or negative 1. So it's going to be 1. Now, 1 is going to be very close to the axis, much closer than I can draw it, because 4,096, you divide this up into 4,096 parts, and you're not even going to be able to see between them. But it's going to come down here at negative 1. Almost to 0. And then when you get out to 2, or to negative 2, y is going to be 1 over 4,096. I didn't explain that. I started with my conclusion. Okay. Y is 1 over 4,096 when x is negative 2. So when x is, that's right. Okay. Yeah. Y equals 1 over 4,096 when x equals negative 2. Okay, so that the graph is going to come down here, and it's going to practically be on the x-axis from here over, because the numbers are going to be very small. Okay? And then we know that if x is 1 or 2, well, when x is 1, it has to be 1, so we're going to have a point here. And we're going to have, when x is 1/2, the value is still going to be 4,096, and we're going to have a graph that does this. So, I don't want to tell you too much about that. Reason it out yourself and see if you can do these problems. See how much you can infer just from this information. The questions I'm asking you are going to be somewhat leading questions. So if you understand even part way what I said here, you should be good.